So in this section, we've been talking about how to divide fractions and whole numbers, dividing two unit fractions, or just dividing standard fractions. So today we're going to start talking about what it's like to divide mixed numbers and how to go about doing that. Our essential question that we talked about was, or for today, is how is dividing with mixed numbers, how is that related to dividing with whole numbers? And then how is it related to dividing with fractions? So let's get started. What is a mixed number, and when will you see a mixed number in real life? So I want you to talk with your neighbor and discuss and figure out, well, what's the purpose of learning how to divide with mixed numbers? Well, some of you guys already know this, and this is the kind of face that you make. A mixed number is a number that contains a whole integer and a fraction. You will see it in many situations, especially situations involving pizza. We know that Miss Kennedy loves talking about pizza and portions of pizzas and how many pizzas you have, so we will probably hear a lot about that today. Alright, so without dividing, tell which expression will result in a quotient that is greater than 1/2 and which will result in a quotient that is less than 1/2. And explain what you know. So you have expression 1, 2, and 3. We talked about how to divide fractions yesterday, or the last time we talked about this, so I want you to kind of think about that and how do we divide them without actually dividing them. I'm going to give you a second to think about that, and go ahead and pause the video so you can kind of work it out in your head or on a piece of paper and figure out which of these three will be greater than 1/2 and which will be less than 1/2. Alright, so we were talking about how to divide fractions without actually dividing them and figure out what the quotient is. Well, we talked about the reciprocal method and how that works. So let's practice this on expression number 1. We have 1/2 divided by 4/3. Okay? If you were to use the reciprocal method, and we know this as skip, change, flip, the reciprocal method says that you are to keep the first fraction as is, change your division problem into a multiplication problem, and then flip your second fraction. So this is the same as 1/2 times 3/4. Alright? So we don't have to divide with this, and we can just multiply straight across. 1 times 3 will give us 3, and 2 times 4 will give us 8. Now think about a pizza. Like I said, we're talking about pizza a lot. If you cut the pizza into 8 pieces, and you eat 3 of the 8 pieces, is that going to be greater or less than 1/2? That's going to be less than 1/2. This is because 4 out of 8 pieces would be half of the pizza. But 3 out of 8 pieces would be a little less than that. Let's move on to the next fraction. So the second fraction begins like this. You have 1/2 divided by 3/4. And if you look at it, you can see that 3/4 here is the reciprocal of 4/3. Alright, let's see if we get a different answer. So if you were to turn this into a multiplication problem, you have 1/2 times 4/3. And when you are cross reducing, make sure you do that after you make the reciprocal. This kind of gives you the wrong answer if you reduce before you find the reciprocal. So let's see what we end up with. 2 and 4 have a common factor of 2. 2 can be turned into 1 because 2 divided by 2 is 1. 4 divided by 2 is 2. So now I have 1 times 2, which is 2, and 1 times 3, which is 3. Now again, we're going to go back to the pizza. If you were to cut the pizza into 3 pieces, and you ate 2 of the 3 pieces, will that be more or less than half of the pizza? Well, you have 1/3 left over, so that would be more. Alright, so let's get into what we were talking about today. we are going to go over how to solve problems with a mixed number. Division. We've got this for multiplication, but let's go on to it for division a little bit. We have, for expression 3, we have 1/2 divided by 1 1/4. Alright, so the first step to do is when you look at the mixed number, you can see that that can be turned into an improper fraction to make division and everything else a little bit easier. So you have 1/2 divided by 1 1/4. Well, let's go ahead and turn it into an improper fraction. We have 1 times 4 plus 1. Your whole number times your denominator plus your numerator. 1 times 4 is 4. 4 plus 1 equals 5. So you have 1/2 divided by 5. That becomes your numerator, and your denominator stays the same, 4. All right? Now, without dividing, we're going to solve this problem. So we're going to use the reciprocal method, which is 1/2 times 4/5. All right? Look at the numbers across from each other, like an angle, 2, 4, and 1 and 5. 1 and 5 have a common factor of 1, but if you divide 5 by 1, you still have 5, so the numbers will not change there. 2 and 4, however, have a common factor of 2. 2 can be divided by 2, and that'll give you a remainder of 1. 4 divided by 2 will give us a remainder of 2. So now you have 1 times 2, which is 2, and then 1 times 5, which is 5. All right? Our quotient is now 2/5. All right, again, think about cutting something up into 5 pieces. If you were to get 2 of the 5 pieces and somebody else were to get the remainder, would you have more or less or equal to half? Well, I hope you know that if you were to get 2 of the 5 pieces, you're not getting half, you're getting less than half. Okay? Alright, let's move on to the next one. Alright, you can extend what you know about dividing whole numbers and fractions to divide mixed numbers. So we're going to find 2 and 2/5 divided by 4/5. Well, the first thing we need to do is number our number line. And I'm going to go from 0 to, I'm going to use blue, 0 to 10. Alright. So what we're trying to find is 2 and 2/5. Well, when I look at my denominator, that lets me know how many parts make up one whole. In this case, 5 parts make up one whole. You're going to split up your number line for every whole into 5 equal spaces. So let's do this in red. So we have 1, 2, 5 equal spaces there. Okay, and I'm going to stop at 3 because I don't really need to go past 3 right now. Okay? So first we need to find 2 and 2/5. Well, 2 is right here. So 2/5 will just be 2/5 over 1, 2. So it's going to be right here. Okay? That's 2 and 2/5. Excuse my handwriting, that says 2/5. Alright, so what we're going to do now is divide our numbers into 4/5. So instead of splitting it into 5 sections, between 1, 0, 0, and 1, you're going to cut one of them out, and it's going to look kind of like this. You're going to start at your 0, and you're going to circle 4 sections. That's 1 of the 5ths. Or 1/4 of the 5. So you're going to see how many 4/5 you're going to get. That's the main goal. 1, 2, 3, 4. Okay. And then 1, 2, 3, 4. Okay, so inside each oval, you'll see you have 1, 2, 3, 4 spaces. I'm going to make sure you check and see if that is right. Your end result is going to be counting from here to here and figuring out how many 4 fifths you have. And we have 1, 2, 3, 4 fifths. Okay? And that's how you do it on a number line. Let's figure out how to do it using our other method we talked about. Okay. Using reciprocals. You can also divide mixed numbers by first writing your mixed number as an improper fraction, then multiply by the reciprocal of the divisor. So first look at 2 and 2 fifths, so about 4 fifths, and turn 2 and 2 fifths into an improper fraction. Well, we know how to do that. We get our whole number and multiply it times our denominator. 2 times 5 would give us 10. And then we need to add our numerator. That should give us 12. And our denominator is going to stay the same, divided by 4 fifths. Alright, when we're using reciprocals, we keep the first fraction the same. We change our sign to a multiplication sign. And we flip our second fraction to 5 over 4. So now we have 12 fifths times 5 fourths. Now before we do anything else, you can see that 5 and 5 have a common factor of 5. 5 divided by 5 is 1, sitting down here. And 12 and 4 have a common factor of 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So now you have fractions that say 3 times 1, and then 1 times 1. Well, 3 times 1 will give us 3, and 1 times 1 is 1. And we know that we only see a whole number over a 1. It's the same thing as saying just that whole even number. So our answer is going to be 3. Alright? Alright, use division to write the distance for the sweet spot for the large end of the bat and a fraction of the length of the bat. Alright, so we see that the sweet spot is 6 3/5 inches long. Alright, we're trying to figure out how long the sweet spot is, what kind of fraction that is of 33 inches. So we're going to divide that by 33 over 1. This is the same thing as 33. Okay? First thing turns the mixed number into an improper fraction. So you're going to get your whole number and multiply it times your denominator, and then add your numerator. 6 times 5 is 30, plus 3 is 33. And fifths. Change your sign to multiplication, and then flip your second fraction to 1 over 33. Well, when you look at this problem, you can see that 33 and 33 are both factors of each other. So if you divide both of them by 33, you'll get a remainder of 1. So you have 1 times 1, which is 1. 5 times 1 is 5. So the distance of the sweet spot from the large end of the bat as a fraction, so the sweet spot is 1/5 the length of the bat. Okay? And let's do one more part before you guys go on your own. You're getting low on dog feed, so you buy a new bag that has 40 cups of food. Your old bag still has 8 cups in it. So each day you feed your dog 2 2/3 cup of food. For how many days can you feed your dog with the food that you have? So here are your answer choices. You have 5, 15, 18, and 28. You need to work alone or with a neighbor quietly and figure out for how many days can you feed your dog this amount of food. Alright, again, you have a new bag that has 40 cups, and then you have an old bag with 8 cups in it. Well, that gives you 48. So see where 2 2/3 of that number will get you, and see how many days you can feed them. All right? Good luck when you are finished. Make sure you show your teacher to see if your answer is correct.